Hello viewers, welcome to video lecture series on sensors and actuators. I am Dr. A. Asunta, Assistant Professor in the Department of Electronics and Instrumentation Engineering, SRM IST, Katankulattur. This is the syllabus for the web lecture series. The first one is first module is the fundamentals and sensor characteristics. So in this module, we are going to see what is the sensor, what is the basics of sensors, transmitter, transducers, and what are the different types of class types and the classifications of sensors, and what are its sensor characteristics, and how to select a sensor. So these basics you are going to see in the first module. And in the second and third module, we are categorized into two types. One is the classification of sensor 1 and sensor 2. In sensor 1, you're going to see all the mechanical, electrical sensors and what are the different types in those electrical, electromechanical, and the mechanical sensors. And in classification of the sensor 2, that is in module 3, we're going to see what is a thermal sensor, and thermal sensor, what are the different types like resistant change type, and what are the different materials are used for thermal sensors. And also we have radiation sensors. All these covers the module 3. So these are the three modules we have going to see only the sensor and its classification. And the remaining two modules, it's completely deals with the actuators. So in the first unit, in the module 4, we are going to see what are the different types of actuators, what are the electrical actuators, pneumatic and hydraulic actuators. And after studying all those sensors and actuators, how to make all the sensors and transducers in a miniature size. So that comes the last module, that is micro sensors and micro actuators. So this covers the entire module of sensors and actuators. So first let me start with the first module, that is sensor and its characteristics. So before that, let me show you some of the instruments, because in a day-to-day life we are using various equipments or various things we are dealing with. So whatever in all these things, so sometimes I can take a vehicle and I'll go and buy some vegetables. I'll take a car and go to my college, and then I'll use mobile phones to see all the to track the things, or I can see whatever the information we want, everything we can see in our latest mobile phones. So whatever the things we are using, everything that plays with or rely on sensors. So just we are going to see some of the sensors now, whatever we are using in our day-to-day life, and how we can use those sensors, how we can relate, that we can see from this slide. So this is, so you all know that this is a personal computer. So but a person is touching the personal computer. That shows that it is a touch screen personal computer. So here, well, how this touch works. So when you use a mobile phone, if you want to see the, if you want to, in early days, we have a small phones. Okay, so the 1100. So there we cannot just every time if you want to go to the back, every time we need to keep on click the buttons. So the using those buttons we have to move to the previous things, or if you want to move to the another. But nowadays we all have the touch screen laptops or touch screen mobile phones. Whatever they want, just we are just scrolling, we are just touching, and if we scroll, it will automatically open. How does happens? There we have the touch sensors. So whenever you touch that, it sends that and makes the things to move up and down to move. If you touch in this direction, it will move to the next slide. If you want to move in the horizontal way or in a vertical, it moves accordingly. So that there we have the touch sensors that plays a role in this. And next comes, this is nothing but an air cooler. Everybody is having this air conditioner AC in our home. So whenever we feel very hot, what will you switch on the AC? So immediately, very soon, or within the 5 minutes, you'll get the room becomes very cold. So that feels as very, very comfortable. But what happens inside? There you have a temperature sensor. So whenever we set the temperature some 25 degrees Celsius, so moment when it reaches the 25 degrees Celsius, it remains stable. So that means once it reaches that temperature, the compressor will be off. Okay. Suppose when I open the door, what will happen? Some hot air will come inside. So that will already it is 25 degrees Celsius. So now the hot air get inside. So that makes the temperature hot air combined with the cold air. The temperature reduces. Now it reduces to some 24 or 23 degrees Celsius. At the time, what will happen? If the temperature goes low, so suddenly, automatically, the compressor will start on. So again, it makes the room cool. So this is what has happened there. The temperature plays a important role to maintain the temperature. So that is the in our cooler we have these temperature sensors. And next comes the this is the motion calling bell, video calling bell. Nowadays, this is mainly it is used for the safety purposes. Whenever a person is alone at a home, so when if any person comes, automatically it will take the photo, and we can see who is standing outside, and we can also see who which person has come into the home. All these things we can see. So if you know known people means you'll open the door, or else it's so this becomes a very safety equipment. So now there we have the motion sensor. So whenever a person comes, it will detect the motion that, and based on that, it will give some notifications to the people. So like these are some of the real-time examples where we can see in our everyday life, we can see sensors plays a main role in everybody's life. Without a sensor, there is nothing. So let me start with the introduction of sensors. So this is just a basic definition for a sensor. So it is a device that detects the response, the physical phenomena. So whenever I say physical phenomena or the environmental change is nothing but maybe a temperature. When you see the air cooler, you have temperature. That is the physical phenomena. Or it will a sensor. What it does, it will just detect the temperature. If it is an air cooler, if it is a touch screen, it will detect the touch, how much pressure you're giving, and if it is a motion, how much the person, how it is, it will detect the person's movements. So like that we have various things. These are all the physical phenomena. So it will measure all those physical phenomena and convert into some electrical signal, so that we call it as sensors. So this is just ready respond to physical phenomena is nothing but by observing or by detecting or and translating the environmental changes like temperature, pressure, motion, light into a measurable signals for the real world applications. So next comes the transducers. So sensor will sense, it will detect and convert. But transducer is the one which convert the one form of energy into an electrical signal. There it will measurable signal, but here it is an electrical signal. Either it will be a voltage signal or it may be a current signal. So transducer is a device which will, whatever the output we are getting from the sensor, that output will be converted into some electrical signal, so that we call it as a transducers. So when these are some of the examples of the transducers, whenever you have a microphone, so microphone what it does is it will just convert the sound waves. So whatever we are talking, that sound waves will be converted into electrical signal. And if another example is a thermocouple, so thermocouple it will convert the what temperature and converts into some electrical signal like a voltage signal. So these are all some of the examples of the transducers. Next comes the transmitter. So transmitter is nothing but it converts the whatever the output we are getting from the sensor, or it may be a transducer. So that will be converted into standardized signals. And whenever I say a standardized signal, it should be some voltage signal, or it may be a resistance, or it may be current. All these will be converted into a standardized signal like 4 to 20 milliamperes. We will not have a 0 to 20. We have the range standardized signal for the current is 4 to 20 milliamperes, and for the pressure it is 3 to 15 psi. Okay, so the sensor output is an electrical, it may be a 0 to 5 volts. That 5 volts will be converted into 4 to 20 milliampere by using some voltage to current converter. So that is what is this transmitters. So there we have the signal conversion. So it will take the raw signals like voltage, resistance, whatever it gets from the sensor, and convert into a usable or a standardized signals that we call it as 4 to 20 milliampere or 3 to 5. Mostly in industries we use the standardized current signal and pressure signal. It is 4 to 20 and 3 to 15 psi. So these are the common types of transmitters. One is the pressure transmitter. You know that pressure transmitter means converts the pressure into some standardized signals. And temperature transmitter, which converts the temperature data which is obtained from the RTD. That these things you are going to see from the next modules. And flow transmitter and level transmitter. All flow means flow transmitters, it will measure the flow and converts. Level transmitters measure the level and it converts. So these are the different types of transmitters. So from these topics, sensors, transducers, and transmitters, they are remembering that sensor, it will measure the physical parameter. Transducer, whatever it gets, measure the physical parameter, convert it into an electrical signal, that is the transducer. And whatever the signal you are getting from the electrical signal, that will be converted into standardized signal like 4 to 20 milliampere or 3 to 15 psi based on the needs in our industries. So next comes the primary measuring element, or we can say primary sensing element. So the primary measuring element is nothing but which element makes the which component that will makes two senses first. So that we call it as primary measuring element. So for example, I can say it may be a temperature. We can measure a temperature. It will sense the temperature, pressure, or the force and converts into a measurable signal that we call it as sensors. Okay, so coming to the example, what is the primary sensing element? So when you take the mercury thermometer, what is the use of mercury thermometer? When you go to doctor, early days, they will use a thermometer. They will keep it on the mouth, and if the person has a high fever or happen automatically the thermometer will show the reading by the mercury level will increase, and we can see the range, what is the temperature. Okay, how this happens? So based on the heat whatever we have in our body, that heat makes the mercury to expand. So due to this expansion, it moves to the particular level. So here the expansion of mercury in that bulb, we call it as primary sensing element or primary measuring element. That will make, after once it sends measure, then only you can see the readable how much it reached. So that we call it as the primary measuring element. I can say another example, that is car tire pressure monitoring system. So in pressure there in the car pressure, tire pressure, you have a inside you have a diaphragm. So the diaphragm of pressure sensor, it will sense the how much of amount of air is pressure is inside the tire. Okay, so once it gets, and then it undergoes deformation. When you apply more of pressure, what will happen? It will undergo some deformation. Okay, so the diaphragm we call it as this primary measuring element. So next comes the actuators. So the actuators are device that converts, sensor means it will sense and converts into some electrical signal, measurable signal, and transducer into electrical signal, and transmitter convert into some standardized signal. This actuator, whatever the output you are getting from the sensor, that output will be, after it goes to the controller, the controller will give some action. So due to that action, it will perform. So that we call it as mechanical action will take place, that we call it as actuators. Convert the energy into motion. Whatever the energy we have, that will be converted into some motion. Then we call it as an actuators. And so let us consider an automatic door. So how this happens? So when a person is far away from that distance, the door will not open. The moment when it reaches near to the door, that means you have some the distance. It will measure the distance. When a person comes to that distance, automatically the door gets open. That means it gets the signal. Signal is nothing but what the person is. Whenever the person, it will just sense this motion, the pressure, not pressure, the person, so immediately it will convert that signal into a mechanical motion. What is the mechanical motion? So to open the door. So this is some of the examples of the actuators. So automated windows, then electric bed adjustment, which is used in the hospitals, okay, and robotic arms. The robotic arms, once the controller, it once it gets the, suppose this is the robotic arm, it will pick some object. Okay, after picking some object, it has to move. So that here the actuator plays a role to make the things to do some action to move. So this gets moves and then it will drop. So these are all the roles of the actuators, electric door locks. So these are all some of the examples of the actuators. So next comes the selection of sensors. So the sensor we have to very important is in industry is we cannot choose the sensor as it is. So we have a certain criteria for selecting the sensor. So the first one is the type of measurement. So what type of measurement you want to? So whether I want to measure a sensor to measure a temperature or pressure or displacement. So what type of measurement that should be noted first one. And second one is the range. Once you're selecting a temperature means temperature sensor means what is the range you want to measure. Whether the temperature is from the 50 degrees Celsius or 50 to 100 degrees Celsius, what is the range that we need to fix. So that is very important. And then, so once you make the range, next one is the accuracy. So how far this sensor will accurately sense the temperature, whether it is meeting the required precision level or not. That we need to check. That is the accuracy. And next comes the sensitivity. So sensitivity is nothing but uh, rate of change in the output to the change in the input. So if it is a very highly sensitive temperature sensor, will detect a minor defect in the temperature. If there is any fluctuation means what will happen that if the sensitivity is very high, then it will minute difference also it will give us an error. If it is a less sensitivity, if it is a 50 degrees Celsius means 50 degrees Celsius, so it will show it as 49.5. Okay, that is nearer to the 50 degrees Celsius. That is light. If it is a highly sensitive 50.1 also, it will not give it as 50. It will show it as 50.1 or 50.2. So that is the role of the sensor which has a high sensitivity. So you can have the example of sensitivity. So just imagine a digital weighing machine which is used in the grocery scale. If you have if it is a high sensitivity, if you add 1 gram, means the display will changes immediately. Note, we can see the changes. How for a small change in input, if there is a small change in input, that will be immediately it will be displayed. So that is high sensitivity. And next comes the resolution. Resolution is the smallest change in the input parameter of the sense that the sensor can detect and reliably measure. So for that, if small changes in the input, if there is a changes in the input, small changes in the input, that sensor will detect. So that we call it as the resolution. So now you have imagine a digital thermometer. So it will show the temperatures from, for example, in steps of 1 degree. So 25 degree, then 26 degree, 27 degree, 28 degree, like that. So now the resolution of the thermometer I can say as 1 degree. The meaning of this is if the temperature changes by less than 1 degree, okay, if it is less than 1 degree means what? I can write it as 25.1 degrees Celsius. Okay, and 26 can be written as 25.9 degrees Celsius. Then the thermometer will never show that will not show any changes, because if it is a 1 degree change, 1 degree changes, then only it will show. If it is less than 1 degree show, it will not show any changes. So that we call it as resolution. Next is the response time. So how much time is taken for the sensor to respond to measure the measure the physical parameter. So that is the response time. And environmental conditions. So environmental conditions we need to, for if it is a temperature, humidity, pressure, all these things we need to consider what is the conditions, environmental conditions before we are selecting any types of sensor, and what are the power requirements is needed for the sensor for the operation. So that we need to that way we have to keep on mind. And then cost and the availability. The budget is very important and cost is also very important, whether the sensor will be available or not, that we need to check. And durability and reliability. So for extreme high pressure and extreme high temperature, it should be robust and have and it should have a long operational life. So these are all some of the things uh, we need to use before selecting any types of sensors. And characteristics of sensors already we have seen: a range, sensitivity, linearity, and hysteresis is nothing but the difference in the sensor output when the input moves up versus when the input moves down. How much amount of input goes up and how much amount of input comes down. That difference we call it as hysteresis. So I can say an example, can consider a pressure sensor. So what the pressure sensor will do, it will measure the air pressure. And how you increase the pressure from 0 to some 100 units, increase 100 psi you increase. So then the sensor will give one set of readings. For 0 to 100 it will give some readings, and then you decrease the pressure from 100 to 0. The moment you increase from 0 to 100 and decrease from 100 to 0, and note down the readings whatever you are getting. Now we find the difference between the sensor output during the increasing state and during the decreasing state. So that difference we call it as hysteresis. So how much amount of the input moves up, the difference between the input goes up and goes down. So that we call it as hysteresis. Then repeatability, the sensor able to produce the consistency every time. If it should first time when you take the readings, if it is 10 20.5 degrees Celsius, and the second time also it will give 20.5, means that's fine. If the next time if it shows 21.5, means there is some error, that should be avoided. Then the drift, gradual changes in the sensor output over a time despite constant output. So you're having a, so that means for over a period of time there should not be any changes. Okay, slowly there should be a changes, that we call it as the drift. So you have a weighing machine that measures some 10 kg of object. Okay, initially first you adjust scale and it will initially it will show some 10 kg. So now over after so many long months, or after a month, or after a year, so again you check. So will it show the same 10 kg? No, it may show it some 10.2 kg. On after a year, it may show some 11 kg, like that. So this deviation we call it as drift. This should be avoided. So we need to take care of the sensors and we need to calibrate it. And then selectivity, the ability of the sensor to detect the desired parameter while ignoring the other inputs. So whatever the other inputs which is affecting, that should be avoided. And remaining thing only we need to consider. So we need to select. So for temperature sensor, I have if I want to measure a temperature, I suppose I have a flow, or I have a flow or level. So we need to consider only for the temperature. So ignoring the remaining things and consider only for the temperature. So that we call it as selectivity. So ability of the sensor to detect the desired parameter while ignoring the other inputs. So far we have seen what are the different types of what is sensor, what is a transducer, then transmitters, and how to select a sensor. What are the different characteristics? All these things we have seen. Now we're just moving to the next, that is classification of sensors. So these are the different classifications. One is the mechanical and electromechanical sensor, a resistive sensor, inductive sensor, capacitive sensor, thermal, magnetic, and smart sensors. We are not going to see in detail. In the next modules, we will see the all the classifications in detail. So in this module, we'll just see what is mechanical, what is electromechanical, just the overview, not the entire in detail. So this is the mechanical sensor. So mechanical sensor is a definition. I can say that it is purely a mechanical device. So what mechanical device is, what it will detect, what it will detect the physical changes. Either it may be a displacement, or it may be a force, or it may be a pressure. So that these are the parameters it will detect. Okay. So these do not require any electrical power to operate and provide the outputs in the form of mechanical movements. So what the working principle is, it is based on the mechanical changes. What is the mechanical changes? It may be a stress, or it may be a strain, or it may be a displacement that is caused by an external force. When external force is applied, so due to the application of the external force, what will happen? There is a changes in the stress, there is a changes in the strain, or there is a changes in the displacement. So that changes only we have to measure. So that is mechanical sensor. So examples we can say that spring balance, then diaphragms and the bellows. So is when you say the spring balance, it will measure the weight. So when you use a spring balance, it will measure the weight. So when you apply some weight, what will happen? It undergoes elongation of the spring. Okay, so that is that elongation we need to measure. Some deformation will take place. And if you take a diaphragm and the bellows, when you give some pressure, what will happen? It undergoes some deformation. That means initially the pressure will be different. Due to application, what will happen? The deformation will changes. So that indicates that indications we need to, the deformation we need to measure. The same we have it for the Bourdon tubes. So this is the mechanical sensor. And comes the next one is the electromechanical sensor. It is a combination of both electrical and the mechanical principles to measure the physical quantities, okay, and then convert into an electrical signal. So this is all these sensors require an external power to operate, whereas mechanical sensor doesn't need any external um, power. So the working principle is it is the sensors are rely on mechanical motion. So the mechanical motion is otherwise a deformation. So due to this deformation, it there is a change in the electrical property. So what is the electrical property will change? It may be resistance or capacitance or voltage. So that whatever the electrical property changes, that will be converted into an electrical output. So for example, when I say strain gauges, so when you apply a strain, what will happen? Due to the apply of strain, what will happen? There is a change in the resistance. Okay, so this we need to put it in the Wheatstone bridge. If there is any changes in the any one of the lead, automatically the bridge becomes unbalanced. So due to the amount of strain, what will happen? There is a change in the resistance. So how much amount of change happens? That will be converted into an electrical signal. Same way for the potentiometers, then piezoelectric sensors and the tachometers. This is some of the examples for the electromechanical sensors. So due to the application of stress is nothing mechanical. So what will happen? Due to that, there is a change in the resistance. That is nothing but an electrical. So this combines together to produce some output. So that's why we call it as electromechanical. It has the combinations of both electrical and mechanical principles. And the next one is the resistive sensors. So in the name itself, we can understand resistive sensors, it will measure only the resistance. Okay, how it will measure the resistance? That is due to if there is a change in the force or pressure when you apply pressure or when you apply a displacement. So the resistive sensor changes when an external factor like a pressure or the temperature that will alter the magnet or the material properties. So due to the changes in the material properties, the resistance will change. So how much amount of resistance change, that will be measured with the help of the potentiometer, something like something instruments to measure that. So strain gauges, so measure the deformation or the strain on an object, and potentiometers. So the potentiometers, you have a linear as well as the angular displacement that can also be measured. So this is the resistive sensors. And the next one is the inductive sensor. So resistive sensor measures the resistance. Inductive sensor measures the inductance, or or the magnetic field, how much magnetic field is present. That can be measured with the help of the inductive sensors. So the working principle is, so whenever a metallic object, when it comes closer to the sensor, what will happen? There is a change in the magnetic field that is produced by the coil. That change, how much amount of magnetic field is changed, that will be that is used to detect. So that is called, that is the principle of the inductive sensors. So here we can use the proximity sensors for detecting the metal. So when you take a in what is that bottle filling system, in bottle filling system, how it will works, coke filling, bottle filling with the coke. So continuously the bottle is coming. So whenever bottle comes to that particular position, what will happen, the bottle will be sensed. So that means it is a, it will, it is, if it is a metal, based on the property, whether it is a metal or a glass or what. So based on that, we have to use sensor. If it is a metal, means you can use the proximity sensor. So when it moment it comes, when the bottle reaches that position, this is the sensor. Moment the bottle reaches the position, automatically instead of running, this will stop. So what will happen then? The coke solenoid valve will open and the coke will fall into this. Coke will be fall filled. So once it is filled, then it moves. The next bottle will come. Suppose you have three things. This is one. There is no bottle here. This is bottle. So when it comes to this position, proximity sensor will sense and it will go. When it comes to this portion here, there is no bottle. So what will happen? It will not stop because it will not detect the metal. So automatically move to the next. And once it sees the bottle, immediately it will stop. So in this way only the inductive sensors plays a role. And next one is the capacitive sensors. So it will measure the capacitance caused by the variation in the distance, or it may be due to distance. Capacitance is nothing but two plates. The distance between the two plates. Okay, and if the area changes, there is a change in the capacitance. So you know the formula for the capacitance is C is equal to, once again. So the capacitance formula is epsilon A by D. If the area changes, there is a change in the capacitance. If the area, as the distance changes, there is a change in the capacitance. So based on the distance and based on the area, and epsilon is the dielectric medium. If the dielectric medium changes also, there is a change in the capacitance. So here the principle is, when an object approaches both, like same inductance approaches a sensor, what happens? Automatically the capacitance change. When it approaches the sensor, what will happen? There is a change. There is a change in area may change, or the distance may change, or the dielectric medium between the plates may change. So due to that, there is a change in the capacitance. Examples, we have the touch screen. In touch screen, we have this capacitor sensors placed, and proximity sensor for non-metallic objects other than metals like glass. Then we can use this capacitor sensors. The next one is the thermal. Thermal is nothing but the temperature. So it will detect only the temperature and convert into some electrical signal. So working principle, this is rely on the material properties. So material properties, here I can say that it may be a resistance or a voltage or a temperature. So based on, if we take some examples in industry, we have to measure the temperature. So there they'll use the either a thermistor or the thermocouples. So thermistor play works on how much amount of change in the resistance with the temperature. If there is change in the resistance, temperature will change. And similarly in thermocouple, so it will generate a voltage. It will produce some voltage. How much? Based on the differences. So thermocouple, this is one plate, this is another. When two dissimilar metals join together, it will generate some electrical signal that is based on the temperature. What is the difference in the temperature? So that is the thermocouple. So we can see the temperature monitoring in heating, ventilation, air cooler, air conditioning, and in industries. If we want to measure any temperature control systems, we need to go for this thermal sensors. And next comes the magnetic sensor. So magnetic sensor is nothing, the name itself, you can understand it is used to detect the magnetic fields and convert into an electrical signal. So this the sensor will measure the how much amount of variations in the magnetic flex, and using some principles like Hall effect and magnetoresistance, it will measure the magnetic intensity. So we can give examples as in all the automotive applications, like speed sense. If you want to sense the speed, or if you want to sense the position, then we can go for this magnetic sensors. And navigation and compasses, we can have this magnetic sensors. So next comes the smart sensors. Smart sensors are so whatever we have seen so far. These are all traditional sensors, and smart sensors are the advanced sensors. It is advanced. Whenever I say smart, is nothing but it has an inbuilt or built in with data processing. The data should be processed by using the sensors and the things. Once the data gets processed, next one is it has to be communicated. So how this happens is, so this smart sensor, it has a combination of sensing. First you have to sense, then it goes processing has to take place. After processing, next one is the networking. Okay, all in a single device. So that we call it as smart sensors. So these sensors, it will take collect the input data. It will collect the data. After collecting the data, process with the controllers. So like a microcontroller, Raspberry Pi, or big controllers. And after getting the processed, the next one is whatever it gets control, whatever the gets controller, it have to communicate. So communicate the result to the other system. How it will get communicated? Through the network like Wi-Fi, Bluetooth, or IoT. So if this we call it as a smart sensors. For example, suppose I have a smart home automation. So everything is automated. Okay, so if there is any problem occurs, if the temperature sensor temperature is too high, or if the light, whenever a person enters, automatically the light will on. If there is no light on me, there is no light is on, so immediately it will send a message to the concerned people. Like that we can make. So the concerned people will see, that will be notified that the light is not on in that particular room. So then he will check all the persons, and they will check, and it can be rectified. So like that we can make. How this happens, that is through IoT, because a person will be in some other place, he may be in remote place, and the home is at in some other place. So how this gets communicated? Through the network like Wi-Fi, Bluetooth, or IoT. So using those networks, they can communicate, and if it is there is any issues happen, immediately that will be sent to the person who are authorized for that, and then accordingly we can solve the issues. So that's why we call it as smart, and everything nowadays it is smart, fully automated. So examples I can say that IoT systems for home automation, and small health monitoring devices like fitness bands. We have fitness bands, everything. So when we keep this, sometimes in Apple mobile phone, the heart rate, or if the heart rate is very high, it will give some notifications. So like that, we can fix everything in our hands and make the everything, all the sensors, we can make it as a smart. So smart sensor is an advanced type of sensor that combines all the traditional sensing element with additional functionality like data. What is a sensor will do? It will just sense and it will give some measurable output. That's it. So once the sensor gets sensed, it should be processed, and then after processing, it should be communicated. Then we can say that as smart sensors. So these are all already have seen: resistive sensors, then mechanical sensors, then electromechanical sensors, and these are some of the classifications of different types of sensors where we can temperature, pressure, force, then acceleration, sound, ultrasound, all these things, where we can use these types of sensors. And sensors based on operating principles, it will be classified into resistive capacitance. So based on the categorization, these will be the name or the classification will be changed. Based on the operating principles, it will be classified as resistive capacitance, inductive, piezoelectric, then electromechanical or electrochemical, like that. Then classification on the type of outputs, we can classify as analog sensors and digital sensors. So analog sensors will give only the analog output signal, whereas digital will give the digital signal. It may be a binary data, it's like a ones and zeros, but these analog sensors will be so whatever the sensor output we get, if you see, if you measure that, you will get. But when compared to the digital sensors, the digital will be far have the more accuracy than the traditional ordinary analog sensors. So examples, I can say that digital thermometers for digital sensors, proximity sensors encoded. So if you take, so nowadays in all the hospitals, they are having this digital thermometer. They're not using analog thermometer. The reason is when you keep the thermometer, it will measure. So my point of view, the temperature is 100 degrees Celsius. But my friend, the point of view, he is saying that it is 101 degrees Celsius. So it's based on the different perspective, it will change. Their opinion will change. Whereas if it is a digital, if they keep the digital thermometer and to check the temperature, it will give the values, right? 90 degrees or 90-degree, like that. So that is more convenient when compared to the analog sensors. Then active elements. So active elements are the components that are capable for supplying energy to the circuit. Active. So we need to supply energy. They rely on external power source, whereas passive elements, that doesn't need any external power source. So examples, I can say transistors. So we need external power supply, operational amplifiers, op-amp, diodes, and integral circuits. All these we call it as the active elements because it rely on external active. If you want to be active, I need a source, some source I need. And passive elements, it cannot supply energy to the circuit. They can only, it will only store and dissipate the energy because it doesn't need any external power source. Example, I can say resistance. So resistance, it will when you see touch the resistance, it's very heated, very hot, right? So that means it dissipates some energy. And then capacitance, so it will store the electrical field. And inductance, it will store the mechanical field. Magnetic field is inductance, and capacitor is the electrical field. And transformers, it will transfer the electrical energy between the circuits for when in the electromagnetic inductions. And classification by the power supply requirement. Here we have two types of sensors, again active sensors and passive sensors. So active sensors already said that it require an external power source. So for thermistors, photodiodes, MEMS, accelerometers, you need an external power supply. Whereas in passive element, it doesn't need an external power supply. You can have the thermocouple. When two metals disconnect, automatically it will give an output voltage. So that can be done using this power classification by power supply requirement. So that's all about the module 1 video lecture. I hope you're all happy to listen my video lecture. Thank you. We will meet you on the next video lecture. Thank you.